Good morning, class 9. How are you all? I welcome you all in today's online class, and in previous classes we have already discussed the previous topics, matter and its classification. So I have already told you matter is it is classified on basis of physical property and chemical property. So in lesson 1 we will just discuss about the physical property of matter, and in previous class I have already told you one thing. In ancient time the scientists believed that the matter is basically of 5 types. You must have heard of it. Chitijal Pavak Gagan Samira. It means water, air, land, sky, and the one missing thing is earth. These are the 5. But now as we just started knowing about all these topics, our knowledge starts increasing day by day and the science become developed day by day. We came to know 3 basic states of matter, and these 3 basic states of matters were as follow, that is written: solid, liquid and gas. So I have already told you about solid, that is hard, simply; liquid, that has tendency to flow; and gas, that is spread all over the room easily. But here I have written the characteristics of all these 3 states of matter. So we start from all these 3. We will understand all the topic one by one and detail formed. Firstly, we will start from solid and liquid and gas. We will explain you in detail. Here I have written solids have fixed shape, size and volume. Simply we can say, suppose I take the example of this mic. Suppose I take the example of this chalk. What you see? It has fixed shape, size and volume also. If you want to check the shape and size and the volume of this chalk, can you change easily? No. It has fixed shape, size and volume too. And here I have written in liquid. Liquid has neither fixed shape, nor size, nor volume. How will you understand that? Take a glass of water and put that water on the ground. What you see? The water starts flowing. Is the water has fixed shape of the glass that it kept in before previous time? No. Means liquid changes its shape and size, but what is confirmed? It has one thing that is fixed, that is their volume. Volume never changes. It takes always the shape of the container in which it is kept. Suppose if you kept in a bottle, it takes the shape of the bottle. It takes you in a bucket, it takes the shape of the bucket. That's on. Okay? Listen. Here in gas I have written unfixed shape, size and volume, and particles are highly energetic. Listen. We already know this Brownian movement, just because of their highly energetic particles, they never be silent, they never be on a fixed place, they always keep moving all around the room, all over the places, all surroundings, in all the surroundings. So here one topic is you are getting one topic, that is Brownian movement. What is Brownian movement? Simply we can say the zigzag movement of the zigzag movement of a liquid or a gaseous particle is called Brownian movement. Take an example. I am telling you. You must have seen sunlight coming from a small hole in a room. What do you observe that? You observe very teeny particles, very teeny dust particles are just moving here and there, hither and thither. Right? This is simply can be said as Brownian movement. In next topic we will talk a strong intermolecular force of attraction between the particles. The particles that solids have very strong intermolecular force of attraction, and just because of this strong intermolecular force of attraction, these particles are very hard. They do not change its shape and size easily until they are increasing pressure, decreasing pressure, increasing the temperature, and many other phenomena are responsible for it. In next topic, less intermolecular force of attraction as compared to solid. Listen. Here suppose I have taken a chalk, or another example, I took the duster. What do you think? If I try to change the shape of this duster, is it easy to change the shape? Not easy, as we think. But if you want to change the shape of any liquid material, suppose I take some water in a balloon and I push that balloon, what do you see? We observe that the shape of the balloon changes easily. Why? Because the intermolecular force between these particles, which particles? The particles of the liquid, changes easily, and just because of it, they changes their shape and size very easily. Why? The reason is less force of attraction. Now the next topic here in gases very less intermolecular force of attraction, and just because of this it shows diffusion and spread all over the room. Do you know what is diffusion? Diffusion means higher concentration to lower concentration. Suppose you burn a incense stick, agarbatti. Suppose you burn a incense stick, after 2 to 3 minutes what do you observe? You observe that the smell, the perfume of the incense stick spread all over the room. Why this is? So you will say that the main reason behind this is diffusion, means the spreading of particles all over that area. Clear? So simply we can say very less intermolecular force of attraction. Now the next topic is very less compressible. Compressible means the tendency to press anything is known as its compressibility. So solid can't be compressed. It can be compressed very less, but liquid can be compressed more as compared to solid. And if we talk about gases, you already know. Do you know LPG, liquefied petroleum gas? What do you observe that? Liquefied petroleum gas means it's a gas, but by high compressing we convert it in the form of a liquid. As well, compressed natural gas, it is also a gas, but applying high compressibility, applying high pressure, we convert these gases as a liquid. So here I have written they are highly compressible. Clear? Gases are highly compressible. Next in solid, high melting and boiling point. What is melting point and what is boiling point? The point at which, the normal point at which any substance start melting. But what type of substance? Solid substances. Solid substances starts melting and liquid starts boiling. So here I have written high melting and boiling point, but here less as compared to solid, because it is already in liquid. If you start giving heat, supplying heat, what will happen? It will start boiling as fast as compared to solid. And here in gaseous particles are, we know already, they are very energetic particles, highly energetic. If we start giving more heat, what will happen? The kinetic energy due to heat will increase and the gaseous particle spread more faster as compared to previous. Clear? Now the next topic is very less spaces between the particles. Solid particles have very less. Do you observe this? Do you think any spaces between this chalk? No. Do you see any spaces between these liquid particles? No. But listen, this can be seen by an activity. I am telling you. Listen the activity very carefully. Actually, take a glass of water and mix some sugar in it. After mixing 2 to 3 minutes, you observe that the sugar has been vanished from the solution. What do you think? Where the sugar has been vanished? You will think, is it a magic? No, my dear students, it's not magic. What happens there? The space between the liquid takes that place. Suppose here I am showing you a drawing. Listen. Here is the particles of liquid. No, I have already drawn. Here is the particle of liquid, and when I start mixing sugar in it, these spaces that can you see very clearly, these spaces are being filled by the sugar, and just because of it sugar vanishes and you are not able to see the sugar and water different from one another. What is the reason behind it? The main reason, the spaces are being filled by the sugar particles that is dissolved in those solutions. Just because of it is said that liquids have more spaces as compared to solid. Clear? Here in gases, as you can already think of it, very larger spaces between the particles as compared to solid and liquid both. Very larger spaces means, how can you think? You must have seen hydrogen gas and oxygen gas. They react to each other and forms a water. So they have also very larger spaces. The air that is moving all around us have very larger spaces. Why you can see? Because you cannot see the air, and one more thing, air have such a spaces that any vacant places, any empty places is just held by the air. Nothing is empty here in the universe, in the world. Where there is nothing, air is present. Okay, clear? The last topic, it do not flow. Why you know? I have written it do not flow. What is the reason behind it? It do not flow because of a strong intermolecular force of attraction. The strong molecular force of attraction bind the particles and they do not allow them to flow. But here, just because of less intermolecular force of attraction, the liquid particles start flowing slowly. And in gaseous, very less intermolecular force of attraction, and just because of less intermolecular force of attraction, they easily move from one place to another place easily. Okay, without any. Listen, the last topic, it is highly rigid. Rigid means hardness or the tendency of unbending. Suppose here is a chalk. You can see here is a chalk and it is very hard. Can you change the shape of and size of the chalk easily? No, you have to apply force. Just because of it, I have written here, it is highly rigid, but it has tendency to flow. Liquid has tendency to flow less because of less molecular force of attraction. So here we can add one more topic I have not written, but you can write, it is not as rigid as solid. Liquid is not as rigid as solid, and in gas it fills the container due to diffusion and Brownian movement. It takes the shape of the container also in which it is kept. Either it is very small in size, very less in size, or in very large in size. If it is very less in size, even then it will fill the total container. And if it is very large in size, if you try to compress it in this condition, it changes its state, and the gases convert into liquid. Got it? So listen now. Here I have written the characteristics of the matters. That was solid, liquid and gas. It is the basic state of matter. Two more matters we will discuss in next class, and those two matters are, here I am writing, listen very carefully. The fourth one is plasma and the fifth one is Bose-Einstein condensate. So in next class we will discuss about the fourth state of matter and the fifth state of matter. These are the first state of matter, second state of matter, and the third was gas. Clear? This is for all today. Have a nice day. Just read very carefully. If you find any mistakes, if you do not understand the topics, any of the topics that I have delivered today, you can ask your doubts personally or in the group also. Thank you.